Hello, physics students. This is Mr. Zamoyski, and today's lesson and activity is going to be on the concept of momentum. Um, I'm sure you've heard of the word momentum used in a variety of contexts in your everyday life. And what we're going to do is take a look at momentum from a physics perspective and how we can make determinations and calculations using the idea of momentum. What I will give you a quick lesson on momentum and an idea of looking at how we can determine changes in momentum. So I'm going to go through the notes relatively quickly, and then I'll have this copy for you to download so you can reference, and then we'll go ahead and do the central activity for this idea of introducing ourselves to momentum. We talked about back when we were introducing forces back in December, the idea of inertia, which is the tendency of objects to resist changes in motion, or objects, simply put, objects keep doing what they're already doing. And we call this mass. So if something has a lot of mass, it's going to be harder to make it start moving if it's not moving, and it's going to be harder to make it stop moving if it already is moving. And we because all matter has mass, then all matter also has inertia. But the key idea is you don't need to be moving to have inertia. And this is where there's often a confusion between the idea of inertia and momentum. Momentum is looking at mass, so inertia, but moving. And there's a mathematical relationship to look at momentum, and that is mass times velocity. So there's a straightforward equation here. Mass is measured in kilograms, v is measured, velocity is measured in meters per second, and then we have this quantity, which is the multiplication of these two terms, which gives us a unit of kilograms meters per second. This is contrary to what we've been doing in physics, where we make up a simpler unit. Here, the unit of momentum is kilogram meter per second.
Momentum is dependent on mass and on velocity. So I can make momentum greater by taking a small mass and giving it a great velocity. I could also take something that's moving very slowly and also give it a great momentum if it has a big mass. I'm going to go ahead and put my car into drive, and then I'm not going to press the accelerator at all, which is going to make my car move forward at about less than 5 miles per hour. But because the car has such a large mass, it still has a very large momentum, since momentum is dependent on mass and velocity. Pretty slow, but still more momentum than a thrown tennis ball.
Momentum by itself, we typically don't do too much with it. Just like what we looked at with energy storage and transfer, we're typically more concerned with the changes in momentum. So for most of the scenarios we're going to look at, that change in momentum is a change in velocity. The mass really isn't going to change in most scenarios that we're going to look at. And so to calculate a change in momentum, you'll multiply the mass times the change in velocity. And for those of you who need a refresher, that Greek letter delta is a symbol that means change in. So for the change in momentum, that is the momentum at the end minus the momentum at the beginning, and the same thing for the velocity. It's the velocity at the end minus the velocity at the beginning. When we're dealing with momentum, or changes in momentum, we do want to look at interactions between objects. So typically, it's two objects running into each other. So you can think bumper cars at an amusement park, a car crash, or any sort of sport activity where you're striking a ball with something else. Or we could consider an object to be a surface. So anytime you're bouncing something off of the ground, there is a change in momentum involved. And anytime you have an interaction like this, you have to be dealing with forces. And so in order to get a change in momentum, you need to have a force present. And this actually agrees with Newton's first law of motion that says an object keeps doing what it's going to be doing unless an outside force acts on it. And so this is where momentum comes into play. We're going to go to Newton's second law of motion and take a look at that relationship. We looked at it in terms of acceleration initially, but Newton's second law can be rearranged to look like the form you see. And you can figure out how strongly a net force is acting on something and its direction if you consider an object's mass and how much it's accelerating. If we go back to one of our first definitions earlier in the year, back in October, we took a look at acceleration is a velocity change over a period of time. So if we turn acceleration into change in velocity over change in time, by doing that substitution and then multiplying this whole equation by delta time, what we'll get is this equation at the bottom here, where we have a net force times a period of time equals mass times a change in velocity. And we've already said that mass times a change in velocity is a momentum. So as a result, we have a relationship here where a net force acting over a period of time is equal to a change in momentum. And we're going to call this relationship the force acting over a period of time that causes a change in momentum. We're going to call it an impulse. And impulse can be the impulse can be determined by the force and the time.
This idea of impulse and the fact that applying a force over a greater time applies to many of your sports. I played baseball growing up as a kid, and I was never really a good hitter. And part of the problem was when I would hit a ball, I wouldn't follow through it all. And so as a result, the ball wouldn't go very far because I was applying a good force, but it wasn't lasting for a long enough time. And so the change in momentum of the ball wasn't as great because it'd be coming towards me at a great speed. And then because I wasn't applying a force for as long of a time, it was leaving with a small velocity away from me and therefore a smaller change in momentum. Something I had to do, and something that all good hitters do, is the follow through. So whether you're dealing with baseball or golf, hockey, tennis, any activity, the key idea is the follow through. You'll have the same force acting for a greater period of time, and as a result, you'll get a greater change in momentum, and your ball will go farther and faster. Home run. Actually, foul ball.
If you have a certain change in momentum, you can change those two parameters and still have the change in momentum. So you could have a very large force acting for a short period of time, or you could have a smaller force that's acting continuously over a longer period of time, and both of these will give you the same change in momentum or the same impulse.
Because a change in momentum or an impulse depends on both force and a time period, I can get the same change in momentum if I apply a big force really quickly, as if just hammering this ball, or I can have the same change in momentum by applying a continuous force for a longer period of time. Now that second kick wasn't nearly as hard, but the change in momentum of the ball was still the same because I applied that force for a longer period of time.
To have you explore momentum and the idea of changing momentum with an impulse, we're going to do an activity, or I'm going to have you do an activity using an egg. What you're going to do is you're going to protect this egg from as high of a drop as you can without the egg cracking. And this is a little bit different than another common version of this activity, because one version of this activity has you construct something around the egg and then you drop the egg and then open it up to see if the egg is safe. This is going to be different because we're just going to keep the egg as it is. We're not going to have anything on the egg, and you're going to drop it and some device is going to catch the egg. And the idea is that the egg should be able to fall from as high as possible without cracking or completely breaking apart. If we take a look at the concepts we just talked about with changes in momentum and impulse, the egg is going to have a momentum right before it hits the ground or hits whatever you're trying to catch it with. Because it's begin falling, its velocity will be increasing, and the moment before it hits, it will have a specific velocity value, and it already has a mass. So it has momentum, and then when it hits the ground, and either is safe or cracks, either way, the final momentum of the egg will be 0 because it has stopped moving, so it no longer has the velocity. And this change in momentum is going to be the same regardless of what you catch the egg with. It will always go from some final velocity before it hits whatever you're trying to catch it with to a final velocity of 0 and therefore 0 momentum. So at a certain height, you can't change the change in momentum, but you do have this impulse. And when we're talking about impulse, impulse is dependent on a net force and on a period of time. So what you can do in order to give the egg a better chance of survival is if you can increase the amount of time it takes for an egg to hit the ground or hit whatever it's making contact with, that will decrease the net force and give the egg a better chance of survival. And so this is the whole purpose of what you're trying to do here. This is how all safety equipment work, from airbags to helmets and any sort of sports equipment. The idea is you're taking some sort of padding or cushioning, and that cushioning will slightly increase the amount of time it takes for that change in momentum to happen, and as a result you'll get a smaller force on your body if you're talking about an airbag as you go forward, on your head if you're talking about a helmet, or on any sort of sports equipment. It's going to take a little bit longer for that change in momentum to happen, and so you're going to have a smaller net force, which hurts less and keeps you safer.
If we take a look at dropping eggs on two different surfaces, we'll see how this impulse comes into play in terms of increasing the time it takes to reach that same change in momentum, which in the case of the egg will be going from some momentum to 0 momentum. I'm going to drop 2 eggs from the same height, so they're going to be traveling at the same velocity because they're both accelerating due to gravity at the same rate, and then they're both going to hit 2 surfaces at the exact same time. But what we'll see is I'll have a surface of grass versus a surface of cement, and we'll see that how the cement is going to give it less time to reach that change in momentum, so there'll be a greater net force, versus the grass, because it's a little more cushiony, it will give it more time to reach that change in momentum, and so as a result it'll experience a smaller net force. Okay, so as you can see, I didn't drop it from very high, but this egg is done for here, versus this egg that dropped on the grass, it's perfectly fine. So that all comes from the fact that the grass is a softer surface, and as a result, it's more cushiony, and so the egg has more time to have that change in momentum, and so as a result, it experiences a smaller net force, and the eggshell can handle that just fine.
To do this activity, there's one thing you need, and that is an egg. And I will give you a little bit of extra time to finish this project, because I know right now going to the store and quickly grabbing some eggs is not really a feasible thing. So you're going to need at least 1 egg to make this happen. And then for materials, I typically have materials that I provide in class, but since that isn't the case, I'm going to let you use whatever you can find at home. So I gave you a list of suggestions there, from any sort of paper products, cardboard boxes if you're getting mail shipments, cereal boxes or any kind of food boxes you have, string, tape, plastic bags, either like the Ziploc kind or the kind you get from stores, balloons. You can go into nature and use leaves and sticks. Paper plates. You can even use water if you want. I'm pretty not putting any sort of restrictions because I don't know what you have available at your house to make this happen. The only thing that I will say you shouldn't use or you can't use are things that you can't dispose of when you're done. So once you're done with this, your egg's going to be all over your device, and it's going to be a mess. So you just want to be able to throw that out. And I'm sure people in your family wouldn't be happy if you're using pillows, which would work great, but at some point that egg will crack and you're going to have egg all over your pillows, and I don't think we want that to happen. So you just use materials that you can find that you can throw away when you're done. And our goal here is going to be to have this egg. You're going to drop it multiple times, and basically you're going to keep dropping it from higher and higher heights until the egg cracks. Once the egg cracks, even if it's just a little crack and not a complete failure of the egg, that's going to be the highest height that you can work with. I'll do an example for, I have something I've thrown together here to give you some ideas on how you can use household stuff. But here's some examples here. of devices that were made in previous years to do this activity. Just to get your mind going for some ideas on how to make a catching device for this project, I just took some materials I could find in the garbage or in the recycling bin, or things that I was going to throw out and or recycle and use those. So what I have here is I have a cut up cereal box. I have a pretty large catching area here, and then I took the extra pieces of the cereal box and kind of made walls here. Something that you should be aware of or try to be careful of is your device may protect the egg initially, but then it could bounce out and land on the ground, and then that you still have an injured egg at the ends, which is not what you want for your safety device. So I have some higher walls here to try and keep the egg within the device once it lands in there. I have some water bottles here, empty water bottles. They're filled with air, so that'll give me a little bit of a cushion, but they're plastic, so they're sturdy enough. So I'm going to stick those two in there as sort of my base, if you can see. And then I'm going to take some very valuable toilet paper here and then just stick it on top to add some extra cushioning. And so I just have, this is my device here. Didn't really take me that long to put together, but I'm looking for something relatively simple, but has a good design with the idea that it'll protect your egg. So I have a large catching area, so there's less of a chance of me missing as I get higher and higher up. I have some high walls, so the egg is less likely to bounce out if it safely lands in here. And then I have some material that can be cushiony, so some air-filled bottles, and then some toilet paper as well to soften the blow. To help you do this activity, I'm going to give you some guidelines. First of all, you're dropping the egg into the catching device. So early on, when you're at low heights, this will be relatively simple. There's really not, it's pretty hard to miss. But once you get higher and higher up, this will be harder to do. So some things you can do to help you with this is you want to stand directly over your catching device. You want to have it eye level straight down into it. Or if you have like a long stick or like a baseball bat or a hockey stick or even just like a long piece of string just to help you keep your aim true, that will be good. Also providing a large landing spot. So I have a pretty large catching area here with my device. So that gives you a greater a greater area to make a mistake. Secondly, you want to do this at a place where it's easy to clean up. So either throw a garbage bag under your catching device, or do it somewhere outside where you can just wash it off or hose it down or something, just to get rid of all the excess eggs, so it's just not sitting there. What you want to do is start really close to the catching device, so just centimeters above it, and then when you're done, go up to the next level, so go higher and higher and higher. I don't know what kind of measuring devices you have, so I'm not going to set any specific values, but you gradually want to get higher and higher and higher. And then you're going to fail when the egg cracks. Even if it's just a little crack, that's like somebody jumping out of a building and getting a broken bone from laying on this device. So that's what your stopping point is going to be. And you can just use rough estimates if you don't have a tape measure or like a yardstick or something like that. So you can go like knee height, waist height, shoulder height, above my head. So those are my guidelines to help you try and be successful at this as we can make this. What I want to do to give you credit for this activity is I would like some evidence of your work. So in order to get the lab grade for this, you're going to send me 3 things. A photo of your finished device, so similar to what I have earlier in this document. You're just going to take a picture of what you made and then show that to me. And then in addition to that, I would like a short video clip of you testing your device, so no more than 15 seconds, just a quick, hey, here I'm dropping it from this height, here's my device, and so on. It may be hard for you to predict what the breaking point is or like when your egg fails, so you can just show me that you're actively trying to test. And then I do want a final answer. You can just send me an email, a brief email, and you can include this in the message if you're emailing me your photos and your videos. of what your maximum height was. So if you have measuring tools, you can give me specific numbers, but if you don't, just give me rough estimates as to what your highest height was. And from there, I'll give you full credit. So I look forward to seeing what you guys do with this and what devices you test and how you make this happen. If you have any questions on making any of this happen, or if you're having issues with sending me photos or videos, please let me know. But I'm looking forward to what you have to do, and happy building, testing, and egg breaking. So let's go ahead and test this and see how well my device does, and then you can compare your results to mine.
I'm going to go ahead and give my device a try. I'll have some actual heights here. I do have a meter stick here, or actually a yardstick. But I'm going to go ahead and just gradually increase the height until my egg is no longer functional. So my first drop will be, I'll just do just an inch above the device, and as expected, the egg is just fine. Let's go with, I'll go 6 inches, so a half a foot. Okay, the egg is still uncracked. I'm going to go a full foot here, so I'll go 12 inches. Egg is still good. Let's go a foot and a half, so 18 inches. So far, so good. Let's go 2 feet, 24 inches. Oh, and that's what you don't want to happen. So 24 inches, it was landed just fine. But unfortunately, it didn't hit a good spot, or it hit a good spot, and then the egg cracks. So 24 inches is going to be my maximum height here. And so you want to try and construct your device to prevent that bounce up from happening. So there we go. So that's just showing you how I want the process to go. So good luck with your testing and working with your devices. When you're done, make sure to clean up. You will have some nice stains on your driveway if you don't do this relatively quickly, and then you'll have some creatures that will try to take advantage of this new meal that's available.